Alright, we are now going to look at doing the partial fraction decomposition of a rational expression. A rational expression is something in which you have variables on top and on the bottom, and we're going to look at how to take an expression like that and break it into separate parts. Now, the first step is if it is not a proper fraction, meaning that the degree on the numerator is higher than the degree in the denominator, then we have to do some division to make it into a proper fraction. And then we'll apply the rest of the steps. If it is already a proper fraction, then we can go right to the different steps. Now, we want to factor the denominator completely into the factors that it may have. They may be of this kind of form, ax plus b to the m just means there may be more than one, or they may be in the form of quadratic, where the quadratic is not factorable. And again, the m and n exponents just mean that it's possible to have more than one of these factors in the denominator. For each of the ax plus b factors, they're going to include the term a over ax plus b, and if we had more than one, then we'd have a1 over ax plus b, and a2 over ax plus b squared, and a3 over ax plus b cubed, and so you can kind of see the pattern there. If we were doing quadratics, we would do a similar thing. And really what this all comes down to is trying to find out the a1, the a2, and the a3 to decompose this fraction. So let's say, for instance, that we started with this example. It'd be a bit easier to see these rules with an example. We have 2x to the fourth minus 8x squared plus 5x minus 2 divided by x cubed, subtract 4x. So that is not a proper fraction. We have x to the fourth here, x cubed there. So the first thing we do is we divide, and it turns out that we can now write it as this can be written as that. And so this one is now in the form of a proper fraction. Okay, so now what we want to do is work on the denominator. We can factor the denominator into x, and then notice if we pull out an x, we would have x squared minus 4, difference of two squares, and so we have three factors there in the denominator. So this portion we're going to decompose into three separate fractions, in which basically we're going to look for the a, b, and c that would go over the x plus 2, and the x minus 2. Basically what we're doing is we're finding three fractions that if we then added those things back together, and of course we would need to make the denominators all the same before we could do that, the result would be this one here. So, as we often do, we're going to multiply both sides by what's in the denominator to get rid of all our fractions. And that would leave us with the 5x minus 2, because again, remember, this equals all of that. So all we would have left is the 5x minus 2. And then in each one of these, we would have what remains of the 3 that wasn't in the denominator. So the first one would have the x plus 2 and the x minus 2. The second one would have the x and the x minus 2. And the third one would have the x and the x plus 2. So again, we took this and divided everybody by the x plus 2, and the x minus 2. Okay, now, while x cannot equal 0, -2, or 2 for the original fractions, because, you know, if we did that, if we put in 0, we'd be dividing by 0, we don't have original fractions anymore, but what we can do is use those numbers, the 0, the -2, and 2, in other words, the ones that would have produced those zeros, we can use them to help us find out what a, b, and c are. So if we let x equal 0, Then on this side of the equation, we would have 5 times 0 minus 2, and then we're just putting in a 0 everywhere we had an x. And the end result is we're going to end up with a negative 2 equals negative 4a, and so that a must be 1/2. Then we let x equal negative 2, so putting in negative 2 for where we had x, and again going through the process we finally end up with negative 12 equals 8b, or b equals negative 3/2. And then the last one, letting x equal 2, we've got the process, and then finally we end up with c equals 1. And so what started out as this rational expression to begin with, we can turn it into this group of partial fractions. 2x plus 1 over 2x plus negative 3 over 2 times x plus 2, and then the x minus 2. And if you're like, well, where did the 2's come from? Remember that a was 1/2, so 1 over 2x, and b was negative 3 over 2. And of course, again, we could add these all back together, and we should end up with what we have there. So a little bit of departure from the matrix manipulations we were doing, but as you can see, we will have a tie-in with one of our examples shortly. So decomposing a rational expression into partial fractions. Let's look at a couple of more examples. Alright, so here we have already factored for us x plus 2 over x plus 1 times x minus 1, and so we're going to suggest that this will decompose into a over x plus 1 plus b over x minus 1. And so this is, we're going to try to find the a and the b. So, like before, first thing I'm going to do is multiply the whole thing by x plus 1 and x minus 1 so that we don't have any fractions anymore. And if we do that, it'll leave us with x plus 2 equal 2. So again, these two will cancel and just leave us with the x plus 2. Here we'll cancel out the x plus 1, so we're going to have a times x subtract 1, and then the x subtract 1 will cancel out, and we'll be left with b times x plus 1. Alright, so let's go ahead and in a similar fashion to our example, let's let x equal 1 and see what that gets us. So here we would have 1 plus 2 equals a times 1 minus 1 plus b times 1 plus 1. And so this is going to result, this part will be 0, this part will be 2b, we're going to have 3 equals 2b, which then means that b equals 3 over 2. And now let's let x equal negative 1. And so we'll have negative 1 plus 2 equal a times negative 1 minus 1 plus b times negative 1 plus 1. Now this part's going to end up as 0. Over here we'll have negative 2a, over here we'll have 1, so 1 equals negative 2a, or a equals negative 1/2. And so we have taken x plus 2 over x plus 1, x minus 1, and turned it into negative 1 over 2x plus 1 plus 3 over 2x minus 1. And that's our answer. We have taken our initial expression and turned it into two partial fractions. So that's the basic idea. All right, in problem 2, note that I have x minus 1 cubed, so I have that 3 times. So in this example, we're going to start off with a over x minus 1, and then b over x minus 1 squared, and then c over x minus 1 cubed. So when we have the same factor more than once, multiplicity of 3 in other words, we're going to have 3 of them in this case. So in this, similar to what we just did, we're going to take that whole thing and multiply everybody by x minus 1 cubed to get rid of our fractions. So that'll leave us with 2x equal to a times x minus 1 squared plus b times x minus 1 plus c. Okay, one of them canceled here, 2 of them canceled there, all 3 of them canceled in that one. So, and similar to what we did in problem 1, we can start off with let x equal 1, and so put in 1 everywhere for x. So we're going to have 2 times 1 equals a times 1 minus 1 squared plus b times 1 minus 1 plus c. Now, of course, this one will give you 0, this one will give you 0. We have 2 here, and so we're going to end up just with c equals 2. So we have our c. Now, we can let x equal anything we want, and a good rule of thumb is to pick some relatively small numbers. So, for instance, we can go let x equal negative 1. And just see what that gives us. So that will be 2 times negative 1 equals, so here be a times negative 1 minus 1 squared plus b times negative 1 minus 1. And here we already know what c is, so we can just say 2. Now, this is going to give us negative 2 squared, so that's 4. So we're going to have a negative 2 equals 4a, and then we're going to have a here, that'll just be negative 2b. And then we've got plus 2. And that we can simplify to 4a minus 2b equals negative 4. So again, negative 2. This negative 2 squared will give us the 4, this negative 2 there, and then the c was plus 2, and all we did was move the 2 over there, so 4a minus 2b equals negative 4. Alright, let's try let x equal 0. So we'll have 2 times 0. Here we'll have a times 0 minus 1 squared plus b times 0 minus 1, still plus 2. Now, in this case, that'll give me 0. This part will be 0. This part will be negative 1 squared, so it'll just be a. So we're going to have 0 equals a. And then this will be minus b. And then we still have our plus 2. And so that can become a minus b equals negative 2, or even a equals b minus 2. And so now I can do a substitution. Since I've got a equals b minus 2, I can substitute it into the equation I have here to solve for a and b. And so let's do that down here. 4 times b minus 2 minus 2b equals negative 4. Let's see, that's going to give me 4b minus 8 minus 2b equals negative 4. So 4b minus 2b would be 2b. Put the 8 on the other side, that will equal 4, which means then that b equals 2. And now that I know that b equals 2, it tells me then that since a is b minus 2, a will be 0. So I'm not going to have an a term since that's 0, but I will have a b term. It's 2, and c is also 2. So the answer to this problem will be 2x over x minus 1 cubed equals 2 over x minus 1 squared plus 2 over x minus 1 cubed. And there's our answer. So, we've seen an example where we had 2 different factors. We've seen an example where we had the same factor 3 times. And we've decomposed them into basically just a number, a coefficient on top of one of the factors. Alright, let's look at our third case. This one has a quadratic in it. Even though it doesn't have 3 terms, it still has the x squared, so that counts it as a quadratic. So that means this one will decompose into a over x plus 1. There's our first factor. And then the second one, bx plus c over the x squared plus 2. So because we had a quadratic, we had to do bx plus c for that one. Okay, going to multiply all of this times our x plus 1 and our x squared plus 2 to get rid of our fractions. And that will leave us with x squared plus 3x subtract 1. By the way, if you were like, is this proper fraction, that only has a power of 2. If you put these two together, that would have been a power of 3. So we were okay there. All right, and then we're going to have our a times x squared plus 2 plus our bx plus c times x plus 1. And we don't have any fractions right now. All right, so let's go ahead and let x equal -1. So first over here, we're going to have -1 squared plus 3 times -1, subtract 1. That's going to equal a times -1 squared plus 2 plus b times -1 plus c, and then we have our -1 plus 1. Alright, so over here we're going to have 1, subtract 3, subtract another 1, so that's going to be -3. Let's see, then we're going to have here -1 squared, so that's 1, 1 plus 2, so that's 3a. And -1 plus 1 over here is going to give me 0, so that's going to wipe out this entire portion, so all we have is -3 equals 3a, and therefore a is -1. Okay, let's let x equal 0. So we're going to have 0 squared plus 3 times 0, subtract 1, a times 0 squared plus 2 plus b times 0 plus c, and then let's see, 0 plus 1. So on the left side, 0, 0, minus 1. And this part here, let's see, what am I going to get? I'm going to get 0 plus 2 times a. And the b will be gone, but I'll have c times 1. So I'm going to have that. And then let's see, let's let x equal 1. So I'm going to have 1 squared plus 3 times 1 minus 1 a times 1 squared plus 2 and then b times 1 plus c, and then here 1 plus 1. Now, by the way, since we could have backed up a step here, since a equals -1, and we have this for our second equation, then that could have become then -1 equals -2 plus c. Since -1 times 2 would give us -2, move the 2 to the other side, and we would have c equals 1. And then this one will give us, let's see, 1, subtract 1, so that's just the 3. And that's going to equal 1 and 2, so 3a. And then we'll have b plus c times 2. But we already know, so we'll go ahead and write that. So b plus c times 2. But we already know what c is, and we know what a is. A is -1, so we're going to have 3 equals 3 times -1 is -3 plus b plus 1, because c is already found to be 1, times 2. And let's see, we can move the -3 over there to make it 6. And so 6 equals 2 times b plus 1. So divide, we have 3 equals b plus 1, or b will equal 2. And so x squared plus 3x minus 1 over x plus 1 over x squared plus 2 decomposed into a was -1, so -1 over x plus 1 plus b was 2, so we're going to have 2x plus 1 for c over x squared plus 2. And so that is our answer for problem 3. Now, honestly, it is a little bit nerve-wracking, to say, well, just let x equal something and then play out through all the algebra. There is another thing we could have tried, which was, let's go ahead and take our original expression. So we had, I'm going to do it in blue here, we had x squared plus 3x minus 1 equal a times x squared plus 2 plus bx plus c, and then x plus 1. So we're going to take that expression after we got rid of all the fractions. And now let's go ahead and expand that and combine like terms. Then this would have been ax squared plus 2a, and then this we would have had to FOIL, so we would have had bx squared plus cx plus bx plus c, and then putting it all together, we would have had a plus b x squared, and then we would have had b plus c x, and then finally a 2a plus c. Now all of that has to equal, of course, that. Now, just matching terms, here we have x squared, here we have a plus b x squared, so that basically tells me that then that a plus b has to equal 1. And here b plus cx, here 3x, so b plus c has to equal 3. And then finally, our 2a plus c has to equal negative 1. So that basically gives me then 3 equations and 3 unknowns. And even though not all 3 equations have all 3 letters, we can just, whichever thing's missing, we can say that that part's 0. So we can set up the method that we did last time, in which we find the determinant and then dA, dB, and dC to find our other terms. So let's take a look at that. So first, our determinant would be, okay, so this is 1a, 1b, no c. The next one has no a, and then it's got to be 1, 1. And then the third one has 2 a's, no b's, and 1 c. And we can go, say, right across the top there. So that's going to be 1 times 1 times 1, 1, 0, 1. And sorry about that. And then that'll be plus 1 times minus 1 times, and now we got to do these two, 0, 2, 0, 2, 1, 1. And let's see, this part here, that'll be 1 minus 0, so 1 times 1 times 1 will be 1. And over here, that'll be negative 1, and that'll be 0 minus 2. So negative 1 times the minus 2 would be plus 2, so plus 2. So that's going to be 3. So D will equal 3. Okay. And now what we're going to do is replace first the A's with 1, 3, negative 1, and then the B's and then the C's to find out our various pieces. So dA, well, that'll be 1, 3, negative 1, and that'll be 1, 1, 0, 0, 1, 1. And let's see, we're going to have, again, if I go across the top, 1, 1, and 1, 1, 0, 1. And then the next one will be 1, negative 1. And it's going to be 3, negative 1. And 1, 1. And so this one again will be 1 minus 0, so just 1. Here we'll have negative 1 out here. Here we'll have 3. Subtract a negative 1, so that's a 4. So that's negative 4, because this will be 3 plus 1 is 4 times negative 1, so that'll be subtract 4, which will equal negative 3. So dA will be negative 3. And then let's look at dB. So now we'll replace the middle column. So 1, 3, negative 1, 0, 1, 1. And again, we'll have 1, 1. But this time we have 3, 1, negative 1, 1. And then we'll have plus 1, negative 1. And this time we'll have 0, 2, 1, 1. So this again is, this is dA there. So now dB is going to be, see, that's just 1, so we'll have 3 plus 1, that's 4. And then over here, that's negative 1, and here we have 0, subtract 2, so that's negative 2, and that's negative 1 times negative 2, so plus 2, so that's 6. and so dB equals 6. And then let's look at DC. So now we'll replace the third column, 1, 0, 2, 1, 1, 0, and now we have 1, 3, negative 1. And so 1, 1, and 1, 3, 0, negative 1, plus 1, negative 1, times 0, 2, 3, negative 1. So DC, well, that's going to be 1. Here it'll be negative 1, subtract 0, so that's just negative 1. And here that's 0, subtract 6, so that's negative 6 times negative 1 is plus, let's see, did I do that right? 1, 0, 2, negative 1, 1, 0, 2, 1, 3, negative 1, so that's 1, that's, yeah, it's just negative 1, and, let's see, did I do this one right, 0, oh, wait, no, that's why I don't have enough here. I went across the top like I did before, so I have to, let's see, so this one is going to be negative 1, and that's 0, negative 6, so that's negative 6. But I left out the third one. The third one would be plus 1, and then another 1, and then it would be 0, 1, 2, 0. And this one would be 1, and then that'd be 0 times negative 2. Let's see, is that right? 0 minus 2 times, let's see, am I doing this right? Wait, excuse me, that's a plus 6. Minus 1, minus 6, so that's a plus 6. And then this part would give me a minus 2. Yeah, and so DC here would equal 3. Yep, had to do all 3 because I went across the top here. So A, second. In the first two they had a 0, the third one, but this one had, so I had to do an extra 1. Now, of course, A, to finish this up, A is going to equal dA over D, which is negative 3 over 3, which is negative 1. B will be dB over D, which that was 6 over 3, which is 2. And C would equal dC over D, which is 3 over 3, which is 1. And so, note, we ended up with the same ABC that we had way back up at the top. Here was our negative 1, C was 1, B was 2, but in this case we used determinants to find our answer. Now, you know, which one's a lot more work? Maybe it just depends on the numbers for our problem, but there was a way to use determinants to solve for the ABC instead of just using algebra. So, a lot there. Alright, last one. This time we have the quadratic more than once. So, this one will be, let's go ahead and do it over here. So we have plenty of room. We got 2x over x squared plus 1 squared and x minus 1. And so that's going to decompose into ax plus b. over x squared plus 1 plus cx plus d, and that's x squared plus 1 squared, and then we have an e over x minus 1. So those are going to be our three partial fractions. So just as in all the other cases, let's multiply everything by the x squared plus 1 squared and the x minus 1 to get rid of our fractions, and that'll leave us with 2x equals ax plus b times x squared plus 1 times x minus 1 plus cx plus d times x minus 1 plus e times x squared plus 1 squared. Now, let's see, let's try let x equal 1. So that'll give me a 2. That'll just give me well, this will all go away because it'll be 1 minus 1, so that'll be a 0 part. This one will go away. That'll be a 0 part. And here I'll have 1 plus 1, so I'm going to have e times 2 squared, which of course will be 4, and so 2 equals 4e, or e equals 1/2. So I found e. Now we're going to do some expansion here of all these terms to see what things would be. So first off, let's do the ax plus b times the x squared plus 1 times the x minus 1. That will equal, when you multiply all those pieces together, let's see, first we can FOIL this. So that's going to be ax cubed plus bx squared plus ax plus b. And now we want to do that times the x minus 1. And so that's going to give us ax to the 4th minus ax cubed plus ax squared minus ax plus bx cubed minus bx squared plus bx minus b. So all of this times these two gave us that. Okay. Now we also have the cx plus d times x minus 1, so we can just FOIL that. Cx squared minus cx plus dx minus d. And then we have the e times x squared plus 1 squared, which will be e times x to the 4th plus 2e x squared plus e. So I just FOILed that part and then multiplied e times each bit of it. But since we know what e is already, that is going to be 1/2 x to the 4th plus x squared plus 1/2. Alright, so I took the first part and expanded it, took the second part, expanded it, took the third part and expanded it. Now what we're going to do is combine all the like terms. So on the one side all we have is x, 2x. Now x to the fourth, I have a ax to the fourth here, and I have a 1/2 x to the fourth there. So I have a plus 1/2 x to the fourth. For my x cubes, I have, let's see, a minus ax cubed here, a plus bx cubed there. There are no x cubes in the other one. So I'm going to have a minus a plus b x cubed. Next, x squareds. So let's see, I've got bx squared. No, I got ax squared. I got b plus a minus b plus c and a 1. So a minus b plus c and a 1 x squared. And now for my x term, let's see, ax, minus ax, so minus a, and plus b, and minus c, plus d, and those are my x's. And then no x's. And that'll just be, I'll just put it right down here. We've got a minus b, a minus d, and a 1/2. Minus b, minus d, and a plus 1/2. And that's the part that doesn't have any x's. So the x fourth, x cubed, the x squared, the x's, and so forth. Now, please note, all we got on this side is the 2x. There is no x to the fourth, so that part has to equal 0. So, for the x to the fourth term, since there isn't anything over here, that's 0. So a plus 1/2 has to equal 0, which means that a equals negative 1/2. For the x cubed term, again, there's no x cubed over here, so this part has to equal 0. So for x cubed, we're going to have negative a plus b equals 0, which means then, of course, that a equals b, which will equal the negative 1/2. So now I have my b. For the x squared, again, all of these are 0, because the only one that 2 is the only one that had an x term. So here I have to have, let's see, a minus b plus c plus 1 has to equal 0. But I know that a and b are the same, so that part is going to be, basically that's going to give me minus 1/2, subtract another minus 1/2. So those are gone, and I'm left with c plus 1 equals 0. Sorry about that. Which means then that c equals negative 1. And then now for the x's, well, we know that we have a 2, so all of those letters in front of the x have to add up to 2. So here, negative a plus b minus c plus d all of that has to equal 2. And so a is negative 1/2, so negative, so we're going to have 1/2 plus a negative 1/2. So of course those will be gone. C has already been found to be negative 1, so that becomes a plus 1 plus D equals 2. And so that tells me that D equals 1. And of course, we already had E as 1/2, so I'll write here just at the very bottom, our beginning point 2x over x squared plus 1 squared, x minus 1, is going to be decomposed into negative x plus 1 over 2 x squared plus 1, and then we'll have a plus negative x plus 1 over x squared plus 1 squared, and then we'll have a 1 over 2x minus 1. And of course the 2's come from those halves. Here A and B both had a half, so that's why we got a 2 here. Here C and D didn't have halves, they were 1s, negative 1 and 1, so negative x plus 1, and nothing down here, and then E had a 1/2. So there is our answer for problem 4. So quite a bit of algebra, but that is the process for partial fractions, or the decomposition of a rational expression into partial fractions.